we'll start with the today's class. So last class we have discussed about some introduction, like how the day-to-day the generation is happening, how the transmission they are doing, and how it is distribution at the receiving end, how they are distributing at the receiving end to the substations. Some ideas we have given. So today we are going to see about the dispatching. Okay, so how the load gets dispatched. Okay, so if you see in us every state, even in our state, there will be of load dispatch center. Okay, load dispatch center, in short form LDCs, LDC, load dispatch center. So what is the role of this load dispatch center is, so all the generation, wherever the generation is happening, so it will all comes to a particular point, grid point. So from that, it will be dispatched. It will be dispatched to different areas, different districts and different areas wherever it is needed. So as you see, like Telangana is a somewhat small state. Okay, so you have to find out what is the installed capacity of the power generation, what is the load, daily load happening in 3 seasons, like in summer, autumn, and as well as winter. So how the load is being consumed in our state, that you need to find out. So being a small state, somewhat small population, so comparatively small, in our state we'll be having only one dispatch center. So whereas in some other states, if you see, like there may be of 3 dispatch center, 4 dispatch center, because the load is very high. Okay, load is very high and ever increasing the load, and due to the managing of the load. So okay, dispatching means say for example, it has to come to a particular point. From that we are dispatching. Okay, so how like a parcel. Okay, if you're ordering any product in online, what they will do is they will dispatch. They will dispatch to say for example, if you're ordering a mobile phone. So how they will do the dispatch means, so that mobile phone will be already having they will be purchasing and keep it in some main dispatch center. In city dispatch center, it will be having some 200 pieces, 1000 pieces. So who are and all ordering, so from that main dispatch center they will be giving to nearby districts. From that districts also, that courier parcel service, they are doing the dispatch. Okay, so all the thing what they are doing is they are making it in a one place. After that they are dispatching. Similarly, like that load also. So wherever the generation is happening, that generation they will give to a one point, single point. Okay, state load dispatch center. So from that there will be like distribution. So which district, whichever the what is the load, so based on that they will be dispatching. Okay, so similarly in Telangana also you will be finding one dispatch center, here in our state, so only one dispatch center. So you'll be finding in Vidut Sauda. Okay, in that place you'll be having load dispatch center. Okay, all over the state, from there only the load dispatch is happening. So it is also called a state grid. Why? Because all the thing is coming there and dispatching. So grid formation also happened there. So it is called state grid. So in that that is the state grid. It is connected to Southern Regional Load Dispatch Center. Whereas this is state Telangana State Load Dispatch Center. So this is located in Vidut Sauda. So it is in Hyderabad, near to Hyderabad. Okay, so from there it is connected to Southern Regional Load Dispatch Center. So there are load dispatch center all over the country. There are 5 load dispatch centers. Okay, Northern Load Dispatch Center, Southern Regional Load Dispatch Center, Eastern, Northeastern, and Western Load Dispatch Center. So where we are connected, where we are connected is Southern Regional Load Dispatch Center, SLRDC. Okay, Southern Regional Load Dispatch Center, which is located in Bangalore. Okay, so from that, some five states are connected. Five states like Telangana, then Andhra Pradesh, Tamil Nadu, Kerala, Karnataka, then one union territory, Puducherry. Okay, so 5 states and 1 union territory is connected to that Southern Regional Load Dispatch Center. So from that only dispatching is happening. So from that, so every minute by minute, second by second, your frequency profile, your power factor profile, then voltage profile, everything is monitoring. Even in our state load dispatch center, even not only in our state, in every state load dispatch center, there will be the monitoring will be there. So the frequency, then the voltage profile, frequency, power factor profile, everything will be monitored. So generally the power factor profile has to maintain that 1. But practically, due to the load increasing in the load, so there will be not 1 exactly. So that they will be maintaining around 0.99 or 0.98. It may be varying. You could not able to tell like this power factor is 1. Okay, ideal system 1, but we have to maintain 1. But practically speaking, it will be like 0.995, 0.96, 0.98, 0.99. Okay, like that. So if it should not cross 0.8, like 0.9 is okay. 0.9 is okay. Okay, it should not go okay beyond the 0.9. Okay, so from 0.9 to 1, 0.9 to 1, 0.95, 0.94, 0.96, 0.98, 0.99. Okay, 0.99 is a good power factor profile. Then and also frequency also 50 hertz. 50 hertz. It also it will be not exactly 50 hertz. Sometimes it will be 50. Then 49.9. Then 49.8. Like that it will be 49.8, 49.7. It might be vary. Okay, so there is a limit for frequency also. It should not go beyond like a 0.5 tolerance limit. Okay, 49.5, or it should not go beyond 51 like that. Okay, 51 it's not possible, and 50 and above sometimes it's possible when load is very low, where generation power generation and distribution is high. In that scenario, it may go up to 50.123 like that. So 51, I don't think so. It is not possible. And it should not go like what I said. No, it should not go beyond 49.5 also. Okay, 49. So like say for example, it is going around 49 or something like that. So every system will collapse. Okay, your cycle. Okay, the frequency cycle will not like it. So some all the system will be get collapsing. Your motor will not run. Okay, it will be get heated up. Some many. So due to the frequency, because your motor is designed for only 50 hertz frequency. If you see the nameplate details, even the pumping motor, if you see in home, so even that also is designed for 50 hertz. 50 hertz. So everything will misbehave. And also, so every state is connected to that Southern Load Regional Dispatch Center. Every state, like I said, Telangana, Andhra Pradesh, Tamil Nadu, then Kerala, Karnataka, Puducherry, every state is connected to that particular Southern Regional Load Dispatch Center. So that Southern Regional Load Dispatch Center also is connected to all over the so all the gridding systems. Okay, it is connected to all national grid. National grid means so this Southern Regional, Northern Regional, Western Regional, then Eastern, Northeastern, everything is connected together. Okay, so all the so one nation, one grid. to the mission of one nation, one grid. Okay, only one grid. Okay, national grid. In that national grid, all these 5 grids are connected. All the 5 grids are connected. So even minute by minute, they will be monitored. Okay, so if you stand in load dispatch center, standing in load dispatch center and working in load dispatch center is not at all an easy task. Okay, so you have to monitor, like like many of the substation and many of the load dispatch center, you'll be finding 3 shifts, like 8 hours they will be doing. Okay, 8 hours, 8 hours they will be doing. Whereas in distribution sector, like in the distribution sector, also 3 shifts are there. So in majority of the almost all substation will be having 3 shifts. So in 3 shifts, what they will do is, why they are going for 3 shifts means, always the monitoring has to be happened in the substations. Okay, because all the substation is connected at the load dispatch center. Okay, every substation is connected in that particular state is connected to the load dispatch center. Okay, so from the load dispatch center, they will be dispatching the load to all the substations in the city and the districts. So wherever you want the power, so all the connected. So in the substation itself, they will be monitoring the frequency profile, power factor profile, voltage profile. Everything will be monitored in the substation. Even current, everything will be monitored in the substation. Okay, so hour by hour, there will be one record will be there. What they have to do is, hour by hour, they have to note down the readings, hour by hour. Like 1 hour, what is today 9 o'clock, what is the frequency profile, then what is the power factor profile, voltage profile, then 10 o'clock, 11 o'clock, 12 o'clock, like that, hour by hour monitoring should be happen. Okay, they have to report from the substation, all the things they have to report to the state load dispatch center. Okay, then that load dispatch center is connected to southern regional load dispatch center, all the state. So even if the frequency profile is not matching, if the frequency profile of, say for example, our state frequency profile is not matching with the southern load dispatch center frequency profile, because there southern load regional load dispatch center, SLRDC, they are maintaining, say for example, 49.9 hertz to 50 hertz. It may be varying, 49.9 to 50 hertz they are maintaining. But even in our state, so we are failing due to some sudden increasing the load demand. So the frequency profile is, we are not maintaining. Say for example, today's date, they are not maintaining the frequency profile. Okay, so what they will do is, from SLRDC, what they will do is, they will be giving 5 minutes or 10 minutes at the maximum time. Within that time, they have to rectify that fault, or they have to rectify that frequency profile. If the frequency profile they are not rectifying means, so entire Telangana will be, entire that particular state will be, not only Telangana, whoever the state not maintaining the frequency profile, they will be islanded from the particular regional load dispatch center. So if they islanded means, what happens means, so we are say for example, we are importing some power from the other states also. Say from Tamil Nadu, we are importing nuclear power, 250 megawatt. Okay, daily our part is 250 megawatt, and from Andhra Pradesh we are getting some power. Like that, we are okay, we are importing some power from other states also, because nuclear power is union government, they are maintaining, they are owned. Okay, nuclear power station is owned by union government. So from the union government, what they will do is, they will have the share. Say for example, 1000 megawatt they are generating now. So 5 states, they have to they have shares. Okay, they have to distribute some 250 megawatt, 250 megawatt, 200 megawatt, depends on the load consumption. The share will be there. Okay, so they have to give. We are getting the power from some other states also. Some power also we are getting from nearby state also, Andhra Pradesh. Okay, so like biogas plant is there. So from that also we are having some share. So like that, we'll see that in detail one day. So we are having the share. Okay, say for example, frequency profile not maintained. So what they will do is they will island. They will simply cut our state. So if it is island, 200 megawatt is 200 or 250 megawatt is deficit for us. And some other thing also, some other power also coming from nearby state, that also will be not coming for us. That is the deficit. Okay, so again our generation is decreasing. Again our resources of the particular day is decreasing to again 250 megawatt, or again some say for example 500 megawatt. So that is the loss for us. So there will be not any okay, they will not do like that. First of all, they have to maintain the frequency profile constant. Okay, they have to maintain the, if suppose by chance due to the fault, or by chance due to the sudden increasing in the load demand, without proper forecasting, if they are going for the in the particular day, or sudden increasing in the load demand, say for example today sudden holiday is coming or something, so the load is increasing like anything. So in that scenario also, a frequency profile is not maintaining, or power factor profile, or in the industrial sector sudden increasing in the demand. So like that, it will not happen. If suppose it happened, it will be island. So this scenario will not happen, because all the industries, say for example, each substation will be connected to some industries and as well as domestic loads. Okay, so in the substation itself, they will be rectifying that fault. They will not take this issue up to load dispatch center. In the substation itself, they know. Okay, because they have to maintain the frequency profile. If all the substation you will be maintaining the frequency profile and the power factor profile, automatically the load dispatch centers profile also will be maintaining the constant. Okay, say for example, one particular substation, the frequency profile suddenly it is getting down. Suddenly it is going up to 49 or 48, like that, 48.5, like that it is going. So they know the particular substation, say for example 5 industries are connected to that particular substation. So 5 industries, what they will do is, they because industries, if you visit any industries, they will be telling. So industries, if they will be having timetable, in what time they have to on the. So while taking the connection, the industrial connection itself, or they have to update in the month or in a week, they have to update the loads regularly. They have to update the loads to the nearby substation. So the timetable, with the timetable, they have to update to the nearby substation. So for example, 6 o'clock to 9 o'clock. So we are running this kilowatt of machine. Then this 10 o'clock to again 12 o'clock, we are running we are having this much load. Then again 2 o'clock to again 5:30, we are running, we are having this much load. Then again 6:30 to again 10 or 9 o'clock we are having. Then around 10 o'clock to early morning 6 o'clock, we are having this much load. So this time load profile timetable, they have to give to nearby substation. They will be knowing. Say for example, without getting the permission, they are going for more load. Without getting the permission, they will say for example, in the particular time, morning is the peak hours. So morning 7 to 10 is the 7 to 9 is the peak hour. So without intimating, if they getting on some other load also, say for example some other load also they are getting on. So what they have to do is, they have to intimate the substation, then they have to on. In the substation, they will be asking to the generation station, like this is the load. So with that load we can manage or not, or so some industries are asking to on the particular load. So we want this much load, like that also they may ask. or sometimes they what they will do is, if the load, some domestic load is very less, they will say okay, if the frequency profile is maintaining constant, then they will say okay, so you can on the particular machine like that. So without intimation, they will be owning, they will be going for sudden on of some other loads or some other machines. Automatically it will be shown in the monitor, that is in the substation. There will be the monitor frequency profile, voltage profile, then power factor. Automatically that frequency profile is getting lowered, then power factor profile not maintaining. So what they will do is they simply cut that feeder. Why? Because they will be waiting for 5 minutes. What they will do is, from the substation, they will be calling to the, they know which feeder, in that, say for example, 3 feeders are there, 4 feeders are there. In that first feeder, the frequency profile is lowering, means the first feeder, say for example 1 or 2 industries are connected, means they will be calling to that industry. So you are getting without intimating, your load is getting increased. If they are telling the false statement, no, like that, they will simply cut that feeder. Why? Because within 5 minutes only, given time. Okay, 5 minutes, maximum 10 for a load dispatch center, 10 to 15 minutes at the maximum, 15 to 30 minutes. If suppose in the load dispatch center, if more than 30 minutes, if they are not maintaining, okay, so automatically the entire state will be islanded. So that is the loss for us. So even the substation and all monitored by the load dispatch center. Even if the substations also not maintaining this frequency profile or power factor profile, they will be also islanded. But it will, this scenario will not do. Why? Because in the substation itself, what they will do is, they will they know, they will call, and they will simply like that, they will cut that feeder. They will open that feeder. If they open the feeder, that particular industry, they will not get the power for 1 hour, 2 hours, like that. So that is the loss for that particular company. Even that particular industry will not do like, like that. If suppose in the false case, if they are doing like that, then that is the loss for them. Okay, so 2 hours, 3 hours without getting the power, that is the entire loss for us, because production will be lost. Then automatically it will be reflecting on the profit of that particular company. Okay, so that supervisor will be there, electrical supervisor or electrical engineer will be there of that particular company. So he will be questioned, and sometimes he will be losing his job also due to this. And also one more thing, very important thing is frequent power factor profile. Power factor profile also they have to maintain. Okay, maintain around 1. Okay, so in every industries, if they are not maintaining the power factor, properly, then that also will be monitored at the substation. And also, so what they will do is, from the substation, they will be going for frequent checking in the industries. Okay, so frequent, so there will be one vigilance department will be there. So in the electricity board itself, you will be finding, so one vigilance department will be there. So what is the role of that vigilance department? In the sense, they will be going for frequent visit to the particular company. So what they will do is, they will be having one device. So if they connect to that particular energy meter of that particular company, so entire, say for example, if they want 30 days, what is the frequency profile? What is the power factor profile? So power factor profile, very important. So power factor profile, if they are not maintaining the power factor profile as 1 or 0.99, then they will be given with a penalty tariff of say for example based on their consumption, they will be given with the penalty tariff. Penalty tariff, if they pay 1 lakh rupees, 2 lakh rupees, more than, say for example, a particular industry is paying 10 lakh rupees of a tariff per month. Per month they are paying 10 lakh rupees. Okay, so in the worst scenario, they are maintaining the power factor profile as less than 1 or less than 0.9 like that. So they will be going for frequent visit, no. So in that, if they nowadays due to the technological development, so whatever the days they wanted, say for example 20 days or 30 days, generally they will be calculating. Generally they are monitoring for 30 days, like per month. Okay, how they are maintaining, like. So in that small machine will be there. So in that machine, it will be connected to laptops or computer. So in that computer, if they type how many days they want, say for example 30 days, 30 days they want means, so 30 days frequency power factor profile will be recorded in that particular energy meter. Okay, so there will be some small memories there, and also it's external memory also there. So that memory that in that if they take now per day, daily what is the power factor profile, and hourly based power factor profile also you can monitor. Okay, so while analyzing all the things, what they will do is they will go for the simple penalty tariff. Penalty tariff 1 lakh, 2 lakh there. So they are paying 1 lakh more means, so definitely that might be the loss for that particular company, particular industry one. Okay, so 1 lakh they are paying, say for example monthly they are paying 1 lakh as a penalty tariff means, definitely like 5 to 6% will lose their job, definitely, because their salaries, definitely that particular electrical engineer or supervisor, electrical supervisors, they will be losing their job. Why? Because they are not maintaining the power. So this also one of the black mark of the company, and also they'll be paying the extra amount, that is the loss for that particular company. So this is in this scenario also will be happening, and in the worst case they will not do like, they will not pay the penalty factor, but sometimes if the load is heavy in the particular generator, sometimes they will be paying some minimum amount of 10,000, 20,000, 30,000 like that. They will be paying in the worst scenario. I'm saying about the worst scenario, they will be paying. If they are paying a penalty tariff means, definitely they are not maintaining the power factor profile like that. So in the industry also, they will be monitoring 5 minutes once. So what they will do is in the substation, if you enter into a substation, so there will be a monitor. In that monitor, everything is the frequency, power factor profile, voltage profile, current, everything will be monitored. So what is the incoming feeder of that particular substation? What is the outgoing feeder? In the outgoing feeder, what is the profile? These profiles are maintained. So minute by minute or 5 minutes once they will be monitored. So if they are not maintaining this profile properly, they will get the call from state load dispatch centers. So not only state load dispatch center, in some other states, what they will do is they will be having 2 or 3 load dispatch centers. In that load dispatch centers, some 5 districts or 10 districts will be connected. Okay, 10 districts or 5 districts, depends on the how many districts are there in the particular state. So all together connected to a common load dispatch center, that is called state grid. So that state grid is connected to the southern regional load dispatch center. That southern regional load dispatch center is interconnected with all the load dispatch center, and it is connected with the national grid. So say for example, in the worst case, southern regional load dispatch center is not maintaining this all the profile. So simply the whole southern regional load dispatch center will be islanded from the all over the nation, that is all over the country. Okay, so this 5 state and 1 union territory will be islanded from the country, all over the country. So they will not get the central part, like union government. They are also owning some other power station. They are also um, producing the power, generating the power, and they are also giving the shares. No, so they will be not getting. Say for example, from the northern region and northeastern region, we are getting we are getting some power from the to the southern region. So that say for example 200 megawatt or 2000 megawatt or 3000 megawatt, something like that we are getting from the southern regional district. So that 3000 megawatt will not getting. So many state will affect. So entire system will be collapsing. So this is the worst case. This is the worst case. It will not happen like that. But even they will not happen because they know, because all the states it is connected to SLRDC. So they know which state is not maintained. Simply like that, from the that thing itself, they will be island, that particular state. Okay, say for example, 2 states not maintaining this profile, they will be islanding 2 states. They only will be the loser because they have to. This SLRDC has to maintain these profiles, frequency profile, voltage profile, and the thing. So for this, what we have to do is in the state load dispatch center, correct, proper, okay, optimal. Okay, so to the point, to the technical point, so optimal dispatching should be happen. Okay, so optimal load dispatching should be out. So there will be many meanings for optimal. Optimal means, so we have to go with the least cost dispatching. So which power generation is least cost, that we have to go for the dispatching. Why? Because if we select the costliest costliest generation and we are going for dispatching, means, as I said, automatically your tariff will be goes like anything. So who will have that burden? Ourselves only, consumers, domestic consumers and industrial consumers. We will be getting overburdened. So our bill. So in our home, we are paying around 1,500 as a tariff per month. Means, so we'll be paying extra 500 or another 1,000 also. So we'll be paying 2 times the tariff, means that everything will be lost.